we're going to start talking about isotopes now, okay? So isotope, what is an isotope? I'm going to show it to you. I'm going to show it to you quick because some of you don't know what it is. I'm going to show it to you, okay? So here we go. Let's take a look at this. We're going to have carbon 12, carbon 13, and carbon 14. There's 3 different types of carbon. Now, here's the question though. Are these all really carbon or is it a different element? That's what I want to know. Is it the same element or is it something completely different now? Davey. So it's a different element? I want to know the elements. I don't want to know anything else. I want to know, is carbon 12, carbon 13, are they carbon?
No, because...
Okay, if they're not carbon, then you have to tell me what it is.
It's like a...
Shh, let him answer.
It's like a positive isotope? Like positive...
That's not what I'm asking you. I'm asking you, is carbon 12 carbon and is carbon 13 carbon?
My sponsor, call extension 2361. My sponsor, call...
So they're all carbon. Well, so if they're all carbon, how many protons does carbon 12 have?
6.
So protons, 6 protons. How many protons does carbon 13 have?
7, 6?
6.5.
I hear it 6, 6.5, 7, but I need a consensus here. What?
6.5.
It's 6 because carbon is still carbon. And element number 6 is carbon.
Yeah.
Carbon 14, is it still carbon?
Yeah.
So how many protons does it have? 6. You cannot change the number of protons. Never. If you do, then it's no longer carbon. If I were to take a proton away from carbon, what would it become?
Boron.
It would become boron, element number 5. Yes. Yeah. So that's how we can, I guess we can. We're starting to create new elements because we're smashing elements together and we're combining protons together to make new elements, right? And the sun combines hydrogen to make helium and other types of elements through nuclear fusion. So there are ways to make new elements, okay? By adding and taking away protons. But if it's still carbon, it's carbon. Now, how many electrons does carbon 12 have? Sam?
6.
Still 6. How many electrons does carbon 13 have?
6.
Everybody, go ahead.
6.
How many carbon 14?
6.
Beautiful. Okay, are we good so far?
Yeah.
That hasn't changed. However, what has changed is the atomic mass. Carbon 12, carbon 13, and carbon 14 do not have the same atomic mass. They have a different atomic mass, which means something did change. And if the protons didn't change, that means the neutrons changed. So carbon 12 has how many neutrons? 6. How many does carbon 13 have? 7. And how many does carbon 14 have? 8. Okay? Now, these carbons, I didn't make them up. These are real carbons that you can find on our planet. Okay? So, if you look at the chart, if you remember that chart I showed you guys, this one says the atomic mass is 12.011. And I told you guys before, the atomic mass is the average. They take all the carbon 12s, all the carbon 13s, all the carbon 14s, add them up, divide it, and you get an average number. So most of the carbons in the world are carbon 12s. But there's a little bit amount of carbon 13 and there's a little bit amount of carbon 14 in the world too. In fact, carbon 14 is radioactive and we use it for carbon dating. So we can find out how old something is from 1,000 years ago or tens of thousands of years ago. All right? It depends. If it's too old, if it gets to millions and stuff, then we can't use carbon anymore. We have to use a different radioactive element. Okay? But yeah, for thousands of years ago, carbon dating is perfectly fine. Perfectly doable. So these, where you have the same element, but different amounts of neutrons. Everybody know what it's called, Davey?
Isotope?
It's an isotope, yes. An isotope is same element, different number of neutrons. So on your quiz or your test, you're going to see same elements, but I might give you the atomic mass. If I give you the atomic mass, you'll see it just like this, and then you'll just put it down. If I don't give you an atomic mass, then you have to use the chart, because that's the average. All right? We got isotopes down. Let's do a different one. Let me challenge you guys a little bit. So I'm gonna make up some numbers here, okay? Let's see how you guys do. So francium. Francium is element number 87. Let's do francium 256. Francium 305. And francium 525. So these are 3 isotopes that I just gave you. I want you to find the protons, electrons, and neutrons for them. I'll give you 2 minutes. Go ahead.
The actual atomic weight is 223.
You're absolutely right. And I'm giving you isotopes.
Oh, you give it? Okay.
Yeah, isotopes are the same element but different number of neutrons. Okay. Well then, Gloria, what element is francium? What element number is it?
87.
It's 87. So how many protons does element 87 have?
87.
Thank you. So I'm going to write 87. How many electrons? 87, yeah. How many neutrons? Give her a chance. I believe in her. Next, we can go with Jocelyn. And then we'll call on Mia. Mia can do the third one.
136.
136? How'd you know that, Gloria? How'd you know it's 136? Yeah, subtracted the atomic mass from the number of protons. That's going to give you neutrons. Yeah, 256 is the atomic mass. I gave it to you.
Wait, now.
Remember, isotopes are the same element with different number of neutrons.
I got 169 too.
Okay, Gloria, did you make a mistake?
I got 137. 136.
All right, hold up.
You see, 136 is the website.
1 second.
Oh, so you're cheating.
Hold up. 256 minus 87 is 169. So 169. Gloria, you might need to buy a new calculator there, okay? Because I don't think that one works that well.
Without a password.
All right, now, second, Jocelyn, I said you can go second. Francium 305. So, francium 305, what's the proton count? 87. What's the electron count?
87.
What's the neutron count? 218. Beautiful. Is that correct? Did her calculator work? Okay, I'm just making sure because I don't have the numbers on me off the top. I would have to do it in my head. But all right, francium 525. Mia? Proton count?
87.
87, okay.
87.
87.
436.
436. Is that correct? Did her calculate?
I got 438.
Okay, hold up. Let's punch it in real quick. I just want to make sure. 525 minus 87 is 438. Okay, so 438.